Hello and welcome back to another LeetCode problem. Today we're going to be doing another daily problem, so it's going to be problem 831, new game. And even though this problem is a medium problem, I think the medium solution of this problem gets time limit exceeded, and the actual solution that you need for this problem is definitely not a medium solution, and it's one that so I got the time limit exceeded with a solution that I considered was pretty reasonable, and then I couldn't figure out how to optimize it further, so I actually had to do a bit of research on the editorial and things like that, and I don't think the editorial is great for this one, so I'm going to try to explain it a little bit better. And so this problem is Alice plays the following game, loosely based on the card game 21. Alice starts with 0 points and draws numbers until she has less than k points. During each draw, she gains an integer, 1 to max points, and she stops drawing when she gets k or more points. And then return the probability that Alice has n or fewer points. So first of all, when I was reading the tutorial and comments, I realized that this explanation of the problem isn't the greatest as well. So one thing I will say, just to clarify this problem, I guess, is let's just think of right away what are the possible solutions we can have, right? So one solution is if k equals 0. So if k equals 0, let's say that, right? So k equals 0, then we can't draw, and then every single number that we have is going to be less than 10. So this output would just be 1, right? But if k is not equal 1, what are the possible outcomes we can have? Well, we stop at k, and the max points we can draw is 10. So actually, the possible range of final solutions we can have is going to be within the range of k to k plus max points minus 1, right? So for example here, if we start at 0, this one's a little bit harder to show, but let's do it for this third one. So our possible outcome is if we get to 17, we stop. But what's the biggest possible number we can reach? Well, the biggest possible number we can reach here is actually we are at 16 and we draw 10, right? So we have to be below k, and then we have to draw the max possible, which would be k plus max points minus 1. So that's the range of possible outcomes that we have for this problem. That's where it ends, and then you just say, okay, out of all of these, which ones are below n? So first, let's try to actually think of the reasonable solution to this problem that would be a medium that probably should have passed on LeetCode if they were going to make this a medium problem. Okay, so how do we get probability, right? So the probability of different things. Let's say we have 3 different outcomes and they all have the same probability, right? So let's say we have count equals 3, and we have 3 different outcomes. What's the probability of each outcome? Well, the way the probability works is it's the number of outcomes times the chance of each one, right? And so if all of these chances are different, then you just multiply them and add them up, right? So you'd have like outcome 1 times p1 plus outcome 2 times p2 plus and so on. But in our case, we have this max points that we can get, and the probability of getting each one of these is equal. So what we're going to do is, let's say we have 10 max points. The probability of getting each one is 1 over max points, right? Which would be 0.1. And then we can just you can see that this could be a dynamic programming solution where we would just see where we're at. We try to iterate through every number in max points, and we just keep adding whatever we have, right? So let's just go through that for something that's, even for example 1, right? So we would start at 0, and then we would say, okay, for points in the range of max points, right? So anywhere from 1 to 10, and then we have some solution, let's just call that S, equals 1/10 times the next case, right? So it would be dp of points, whatever current, so let's say p is what we currently, or not p, let's just say like total or something, right, is the points we have. So then this would just be total plus whatever we added, right? So this 1 through 10, so let's just call that I. And we sum all these up, And then let's also think of the base case. So the base case is, once again, our ending states are going to be anywhere from k to k equals max points minus 1. And so that's pretty straightforward. Anytime we get to a value that's greater or equal to k, we just check, is that value less than or equal to n? If it is, return 1, because that's a valid value. If not, return 0. And so we take all these DPs and then we just do 1/10 times each, and whenever we get a final outcome, we actually add 1 or add 0, and then we'd return that. And we also have, because this is going to be dynamic programming, we can have a memoization array for, let's say we're doing top down, for all the different states we can be in, right? So for this one, we can be anywhere from 0 to 10. So we would just, anytime we get to something and we did it again, we would do that. Because we can get to the same state twice. Like, let's say, for example, 3, we start at 0, right? So we start at 0, we draw 1 point, and we're at 1. Well, we can draw 2, we can draw 3, and so on. I'm not going to draw out the whole thing, but yeah. But then what if we draw another 1 point here, and now we're at 2, and this 2 is the same 2? It doesn't really matter how we got here. The same solution for the probability of getting this from this 2 and this 2 is the same. So you're going to have a lot of repeated work, so you're going to want to have memoization. So I do have some code for memoization, so I don't want to show the other one yet. Okay, so I think this is going to be that. So for this code, well, actually, I can show the last code. It doesn't really make a deal. So let me actually comment out the code for the final solution, and we're gonna look at this original code here. So I believe it's just this. Okay, so let's take a look at our memoization. So first of all, I actually tried to make this problem pass with the memoization. So I tried to make some optimizations that I thought, maybe it's close, I'll do that. And so if k equals 0, we're guaranteed to have an output of 1 because we can't move at all. And so we start at 0 and every number is going to be below 10. And then also, if the biggest possible number we can reach is less than or equal to n, so let's say, actually this would work for this case, right? So what's the biggest possible number we can reach? It's 10. If 10 is less than or equal to 10, that means we know we're going to return 1 because that's the farthest we can go. And then also looking at it the other way is, if k is greater than n, so let's say if k is 11, then we're never going to stop at 10, so we're going to return 0. So that's some optimization tricks you can have to. It's not gonna lower the runtime complexity, but it will make it run a little bit faster on LeetCode. Okay, so let's take a look at the memoization solution first, and then I'm going to explain the other one, which is definitely a lot more complicated. So this is pretty straightforward, right? This is our base case. So if points is the current point we're at, and then we have this visited. And so if points is greater than or equal to k, that means we are done, right? Because we stop when we're at k. And then we just simply return 1 if it's less than or equal to n, or we return 0. And then we check, is it in our memoization array? If it is, we can return it. And then this is the other one. If points is greater or equal to n, then this is also a 0, right? Because, so I think actually these optimizations don't need to be needed for this dynamic programming, because I do have a little bit of repeated work, but whatever. But I added them to the other one as well. So these are all the base cases. Now what we do is, I actually didn't need this chance as well, because what I could have done, was I could simply take whatever total value I get in my dynamic programming solution at a current stage and just divide it by max points. But I think it makes a little bit more intuitive sense of how you do probabilities with chance. So chance is the probability of each outcome, right? So if we have 10 max points, the probability of each different number we can go to is going to be 1 over max points. And then I have an output. And then we simply iterate through every single number from 1 to max points, because if max points is 10, we can go anywhere 1 to 10 up. So then we have res plus equals chance of dp of whatever one we get to. So every single one has probability chance times the probability of getting there from that next number we get to. Then we just return. And so if we actually try this on LeetCode, you can see that these cases pass, but we get a time limit exceeded. So they want a better solution. And the problem with this is we are doing repeated work, because we are summing up. We're still doing repeated work because we are summing up all these probabilities. So even though all of these points are in the visited array, so let me show you actually what I mean by that. So let's take let's take this one right here, and we're just going to draw an array of the final states of the solution, right? So we can be at 17, all right, hold on. So we can be at 17, 18, 19, 20, yeah, 21, 22, it goes to, let's see here. Yeah, so it can go up to 26, right? So 21, 22, 23, 24, 24, 25, 26, and let's draw an array. Okay, so my drawing is a little bad, but it's okay. Okay, so these are the final states. And when we actually, so, and by the way, so what would these be? So n is 21, right? So anywhere from 21 or less would be 1s, but these are 0s. And I'm actually going to draw another array under this one, just because I didn't have room over here, with some earlier states. Okay, so let's say this is 16, 15. I'm not going to draw. We're not going to go all the way down, but you're going to see the pattern here. Okay, so when we're trying to get dp of 16, so we're at 16, we can get to any one of these numbers, right? Any one of these. And so let's even do that. Actually, it doesn't matter. So we can get to any one of these numbers. So dp of 16 would be, you have to treat this as a sliding window, and so the left would be here of this sliding window. And we can figure that out because we can simply loop from whatever number we're at to the next max numbers, right? So from 16, we can loop to the next 10 numbers because max numbers is that, and we can sum it up. But what we can do originally is we can actually have a starting sum. So let's say we sum these up in the original, and we call this like sum, okay? And this is going to be 5. And so we're going to actually loop through everything before this number all the way down to 0. So we're going to loop all the way down to 0 here. Let's just pretend this is 0 and this is some stuff. And then this is going to be what we're going to be doing. So let's say we're at 16. Well, if we're at 16 first, we can just take our sum, right? Because it's already computed for us. So here it's going to be 5. And also, by the way, so we not only do we take our sum, we actually need to divide the sum by the total numbers starting at all these. So it's just going to be 5 over 10 here, right? Now, what we need to do is think about the work we need for 15. Well, for 15, we need the next 10 numbers. Well, we have the next 10 after 16, but all we have to do is, from our sliding window, we just have to get rid of the last number. So once we get the 16, we just have to get rid of the last number. And now we move this left pointer over here. And then we also have to update our sum, right? So we have to update our sum. So we had 5. We subtract 0, so that's still 5. And then we add this 1/2. So now it would be 5.5, right? So 5.5. And then for 15, when we're getting the next 10 numbers, it's going to be these numbers. So this and this. And so that's going to be like 6 or 5.5, right? So it was already computed for us. And because because in this dynamic programming array, you know which numbers you're getting, all you have to do every time you move down is you have to subtract from the very end and then add from where we're at, and that's gonna be all the work we need. But because in this memoization, what we were doing is even if we had access to all of these numbers, what we were doing is we were summing up this, and then we were summing up these 9 and this one. So we were doing a lot of repeated sum work, and that's what makes it so. So not only do we have to have constant time lookup of these numbers, we also have to have a constant time lookup of the sum. Okay, so hopefully that makes sense. And let's take a look at the code here, and we're going to comment this out, and we're going to take a look at this code and explain it. Okay, so like I said, these are the small optimizations you can make. I think it'll still pass without these, but you know, they make it run a little bit faster on LeetCode. And so, oh, actually I have them twice, I believe. Yeah. Okay. So let's just make sure this runs still, and then, okay, so it does run. Okay, so let's go over it. And we'll have the picture as well. So total equals 0, total is our sum. And then we have this DP array, and remember the last point we can get to is k plus max points, or it's actually k plus max points minus 1, but we also need something for the 0, right? So that's why this is the length of the DP array. Now what you could also do is, I don't even think, no, I think you do need a DP array, but you might be able to get away with just using a sliding window instead because you only need the next 10 points. So technically, I think you could get away and you could try to code this up. Instead of this whole DP array, you could actually use a sliding window of 10 points because it's kind of like a house robber, right? If we're only going to the next 1 or 2 elements, we don't need the entire array. We can just have the next 10, and that would be fine. Okay. And then we just simply remember what indices we're at. So if you want to save, if you want to do a slight memory saving technique, that would work. Okay. So this first loop is basically this picture right here. So we're just going through the possible ending points, and we're saying, okay, if that index is less than or equal to n, then we're going to make it 1. Otherwise, we're going to make it 0, and we're going to add these up to the sum. And now we're going back. Remember, so our first index is k minus 1. So if k was 17, our first index would be 16, right? And then we go all the way down to 0. And so dpi is total over max points, kind of what we did here. So we took the sum over whatever our length of the array is, and then we just subtract the index of, so remember the last element we accessed from the current location is I plus max points, because this array is going to be max points length. So we subtract I plus max points, and then we add in the current value that we just had, and then we just go backwards. And at the end, what we need to do is we need to return this dp0, because this dp0 is going to be the probabilities of everything starting at 0, and that's what the problem's asking, right? We're starting at 0. And so let's think of the time and space complexity for this problem. So time. So what we're doing is we're gonna stop at k plus max points, right? Like the biggest possible number here is k plus max points, because that's the stopping location. So that's going to be the time, is it's going to be k plus max points. And we are just we're just going back, so that's going to be linear time. And then space, we made an array of k plus max points as well, right? So it's just k plus max points as well, because it's a standard sliding window. But it's, yeah, I definitely don't think it's a medium problem, because it's a sliding window combined with dynamic programming, which is quite confusing. So hopefully that makes sense to you. And if you have any questions, you can write it in the chat, and I'll see you in the next one.